Imagine you're running late on a snowy morning and you rush outside, and the moment your feet hits the pavement, you realize it's a sheet of black ice. Your movement strategy immediately changes. You take shorter strides and you flatten your feet. You didn't need any instructions to do this. You simply adapted from a lifetime of experience. Now, if you were a conventional robot with wheels or legs, you most likely would have failed. Most robots today are designed with a pre-programmed way of moving, and when the environment changes to something drastic or irregular, they most times fail. In my research, we try to tackle this by taking two approaches. One is a nature-inspired approach through biology, and the other is through machine learning, basically trying to teach the robot how to move. Now, when I talk about biology, my research centers around bio-inspired robotics. And for my own particular work, I've been inspired by a sea turtle. And when you think about sea turtle, you might think about cuteness. But when they're at the early stage of their lives, they have to navigate rocks and sandy beaches to get to the ocean. Now, our end goal is to build an amphibious robot. And to build such robot, we took the inspiration from the sea turtle. But having a great body is not enough for practical purposes. We need to find a way to get the robot to move effectively. And that's where the machine learning comes in the form of reinforcement learning. In short, it's simply getting the robots to learn through trial and error. Basically, in simulation and experiments, we expose the robots to a variety of environments which it might encounter in the future, and get it to try a variety of movement strategies, like move quickly, move slowly, have this alternating movement of the flippers, or have all flippers move synchronously. It tries this, it also tries different frequencies, just to get the perfect combination of all these movement strategies that would allow it to be successful on a variety of terrains. Now, when you deploy such robots in these environments, which are like real-world environments for like environmental monitoring, search and rescue, or like agricultural inspection, you don't want the robot to fail. You don't want it to fail in its mission. And if you have a robot that cannot move in these environments, the mission is practically over. Think about the Starship robots, which you must have seen around campus delivering food. On most snowy afternoons, I see it stuck on snow, and I guess they didn't program this robot to find a way to move when it encounters snow. But my research is trying to bridge this gap. Basically, we're combining nature-inspired design with this experience-based learning to develop robots that are adaptable and useful for real-world and practical purposes. Thank you.